A very good morning to everyone. Today's session I'm going to explain some basic terminology in machine drawing. So generally drawing, what is mean by drawing? The art of representation of an object by systematic lines on a paper is generally called it as drawing. So sometimes we call it as artistic drawing if we draw with freehand or model or model drawing. So, and engineering drawing, the another terminology engineering drawing. So, engineering drawing is also known as instrument drawings. So, coming to engineering drawing, it is an art of representation of engineering objects such as buildings, roads, machines, etc. And a paper is generally called it as engineering drawing. And coming to mission drawing, so mission drawing, coming to our subject, mission drawing, it's an art of representation of mechanical engineering objects such as missions, mission parts, mission tools or mission tools on a paper. Is simply known as mission drawing, or mission drawing is also known as mechanical drawing. So if you represent any engineering objects on a paper, we call it as mission drawing or mechanical drawing. So we are representing mechanical objects. So coming to production drawing, another terminology, production drawing, very important. Uh, in production drawing, in generally a drawing which provides complete information for the production of machine or structure. Simply we called it as production drawing. So production drawing is also known as working drawing because it provides complete information for production of that particular machine or structure. So that's why we call it as production drawing. So this is a diagram for mission drawing. Here you can see mission drawing, generally it is a piston. One of the example here, the example is piston. So it provides all the views, front view, top view and side views. All the orthographic views are given here. So here you can clearly see, you can see that it shows all the dimensions clearly, and also it's bill of materials. Yeah, another terminology, bill of materials, shows all bill of materials or parts list. So it clearly shows that the different parts in that piston, overall piston, engine piston, piston pin, piston plug, and piston ring, and the type of material and type and the quantity. That quantity also clearly mentioned in the bill of material. So this is how that mission drawing looks like. Coming to production drawing, the difference between the mission drawing production, you can here same piston represented with some orthographic views along with some tolerances. It clearly mentions some tolerance. Here you can see some rectangular boxes. Here you can see some boxes which contain some symbols. The symbols represents a type of surface finish and also the tolerance limits. So it provides complete information, whereas in mission drawing it only gives you dimensions and bill of material. It clearly mention all total information to produce or to manufacture any product. This is actually the production drawing. Coming to the very important thing, types of dimensioning. So in drawing, the dimensioning generally classified into two types. One is aligned system and unidirectional system. So aligned system and unidirectional system. So what is aligned system? Here you can see two types of dimension system. Here you can see the two figures. In aligned system, dimensions are placed perpendicular to the dimension line. Here the dimensions are placed perpendicular to dimension line. It means we can read dimensions from bottom or right side, from bottom side or right side. That means they are placed perpendicular to the dimension. Those dimensions are placed perpendicular to dimension line. Again, those dimensions can be read from bottom or right side. Coming to unidirectional system, another system. Unidirectional system, second system. So in unidirection, the dimensions are broken. The dimension generally we placed those dimensions. How we generally place it means the dimension lines are broken near the middle of the dimension line, and for inserting the dimensions. So here we broken those dimension lines at the middle to insert those dimension lines in such a way that they can be read from bottom of the drawing. So they can only read from bottom of the drawing sheet. Okay. Whereas aligned system, simple difference. Aligned system we can read dimensions from left hand, from bottom side or right hand side. Whereas in unidirectional system we can only read from bottom of the drawing sheet. So these are generally, this is actually JNTK syllabus. Just what are the various simple syllabus. What are the elements? Complete syllabus. The first part A, JNTK syllabus. It is actually JNTK syllabus. Part A, drawing of mission elements and simple parts. So this is all part drawing. Part drawing. These are all part drawings. Mission drawing conventions and convention. Coming to conventions. Conventions nothing but any symbol or sign to represent any object. So screw threads, bolts, nuts and stud bolts, key, quarters and knuckle joint, rivet joints, shaft couplings, socket and spigot pipe joints, journal, footstep bearings. These are all this content is comes under part A. Part B assembly drawings: engine parts, screw jack, mission wires, lathe tail stock, plumber block, feed check ball, spring loaded safety ball. So these are all actually the syllabus. I just want to show you some syllabus. What are the content of JNTK syllabus? This is part B of mission. Thank you.